Alright, so in this problem, what we first got to do is figure out what's going on in this picture. You'll notice we got this curve. It's in teal, or whatever color that is. That's that shape right there. And it's labeled pretty clearly. This line AB, that's a tangent line. They tell us that. It goes through point 1, 2. That's the point of tangency. That B is going to be a y-intercept of the tangent line. Let's see, what else can we figure out? We can figure out that this AC, they tell us that's the normal. And obviously C cuts the x-axis, so that's an x-intercept. All right, so the first thing we got to do is we got to find out what the tangent line's equation is. Well, we got to find the tangent line and the normal, and luckily they both go through the same point of A, which is 1, 2. So we already know our point. What we need to do is figure out our slopes. And we're going to use a derivative to find the slope of the tangent line. And once we have that, we'll take the opposite reciprocal, and that'll be our normal. So we do the derivative here. We're going to do the chain rule. Bring down the 1/3, put it in front. Knock this down by 1, and then multiply by the derivative of the inside. And of course, then we got to multiply, and then we're going to bring this back down. It's going to be 2 over the cube root of 6x plus 2 squared. All right, so now we got to put our x value of 1. That's the point of tangency. And keep in mind, in derivatives, we're only going to put x values in. And so when we put the x inside here, well, that's going to be 6 times 1 plus 2. That's going to be 8. 8 squared is 64. So basically what they're talking about is the cube root of 64. Well, that's going to be 4. So 2 over 4 is 1/2. And that's the slope of our tangent line. So once we got that, we can easily figure out what the slope of our normal line is. That's going to be -2. So now we've got both our slopes, and we're going to use the same point because they go through the same point. We plug them into y equals mx plus b. We find out what the y-intercept is. For the tangent line, it's going to be 1.5. So y equals 0.5x plus 1.5. That's our tangent line. We go back and do the same thing for the normal. Y equals mx plus b. Plug in the point. Find out the y-intercept. It's going to be 4. There's our normal. Now, part B, it says find the distance BC, basically the length of BC. Now, keep in mind, that's the y-intercept of the tangent, that's B. And then C, that's the x-intercept of the normal. So all we got to do is figure out the x-intercept of the normal. Plug in that, we're good to go. And now we just got to find the distance. And we're going to find out it's 2.5. Now for part C, we're going to find the coordinates of the intersection of OA and BC. Well, BC, we already know those points. O is pretty easy, that's the origin. A, we know that's 1, 2. So all we got to do is find the equations of these lines and then solve them simultaneously. Well, this isn't too hard because you'll notice 2 of the points are y-intercepts. All we got to do is find the slopes. The one slope for BC, that's going to be -3/4. And then the slope for OA, that's going to be 2. And since BC's y-intercept is 1.5, I already know that. And since OA's y-intercept is 0, 0, I already know that. All I got to do is make them equal to each other. Solve for x. I'm going to find out that x is going to equal 6 over 11. And then I plug it back into that y equals 2x, and then I'm going to find out that the other y, my y is 12 over 11. Then the question is it the midpoint? Well, no, it's not the midpoint, because the midpoint of OA is actually 0.51, which is really close to 6 over 11, 12, 11, but it's not the same. All right? Thanks for watching. Hope that helped.